Next part, the squeeze theorem. Suppose that the gx is less than or equal to f of x less than or equal to h of x for all x in some open interval containing a, except possibly at x equals a itself. Suppose also that limit of the gx equals limit of the sx as x approaches a equals L. Gx is the left function, Hx is the right function. If the two functions on the left and on the right side of the function f of x approaching to the same number L, that makes the limit of the fx, which is the middle function, approaching L as well. So that's why it's called the squeeze theorem. In this example, if 1 minus x squared over 6 less than or equal to x times sine x divided by 2 minus 2 times cosine x less than or equal to 1 for all values of x close to 0, we are going to find the limit of the middle function as x approaches 0. By squeeze theorem, we find the limit of the left function, which is 1 minus x squared over 6 as x approaches 0, which gives us 1 minus 0 or 1. And the limit of the right function, which is 1, as x approaches 0. Since both of them are polynomial, we can do the direct substitution. As you see, the limit of the left function equals limit of the right function. Therefore, by the squeeze theorem, the limit of the middle function, which is x times sine x divided by 2 minus 2 cosine x as x approaches 0 equals 1. For this example, use the squeeze theorem to verify that limit x squared times sine of 1 over x equals 0. We are going to form the inequality of the three functions, while the x squared times sine of 1 over x is the middle function. Let's look at the sine. The sine graph is the graph that's periodically up and down, the maximum at 1, minimum at -1. So we can form the inequality by making the inequality of sine of 1 over x between -1 and +1, and then multiply all three portions by x squared. -1 multiplied by x squared less than or equal to x squared times sine of 1 over x less than or equal to 1 times x squared. Therefore, the left function is negative x squared. The middle function is x squared sine of 1 over x less than or equal to the right function, which is x squared. By the squeeze theorem, the limit of negative x squared as x equals 0 equals 0, which is the same as the limit of the right function or the limit of x squared as x approaches 0. Therefore, by the squeeze theorem, the limit of x squared times sine of 1 over x as x approaches 0 equals 0. Next, evaluate one-sided limits. This example, use the following function to answer questions A and B below. We have the piecewise defined function f of x equals 6 minus x as x less than 4, and f of x equals x over 2 plus 2 as x greater than 4. The limit of f of x as x approaches 4 negative is the limit of the function when x is defined for x less than 4, or the limit of 6 minus x as x approaches 4 negative. And this is a polynomial function. We can use a direct substitution, and we get 6 minus 4 or 2. For the second one, so the limit f of x as x approaches 4 positive or coming from the right side, or where x is greater than 4, we can use the function x over 2 plus 2 as x approaches 4 positive. Again, this is a polynomial function. We can use the direct substitution to get 4 over 2 plus 2 or 2 plus 2 or 4. And these two limits, the left-sided limit, the right-sided limit, they are not the same. Therefore, the two-sided limit or the limit of f of x as x approaches 4 does not exist. In this example, limit square root of x minus 3 as x approaches 3 positive. Since the square root of x minus 3 is defined for x greater than or equal to 3, which is the domain of this function. So limit as x approaches 3 positive can be defined as square root of 3 minus 3 or 0. But the limit square root of x minus 3 as x approaches 3 negative cannot be considered or not available or doesn't exist because x greater than or equal to 3 is the domain. So anything less than 3, the function is not defined, so the limit doesn't exist. In this example, we determine a value of the constant a, for which the limit gx as x approaches 1 exists, and state the value of the limit if possible. We have the piecewise defined function. For x less than or equal to 1, the function is defined as x squared minus 7x. For x greater than 1, the gx is defined as ax to the third minus 5. So the limit of gx as x approaches 1, which is the two-sided limit, exists if and only if the limit of the gx from the left equals the limit of the gx from the right. Okay, so we're going to find the limit from the left side or the left-sided limit of the g, which is the limit of x squared minus 7x, because x less than or equal to 1. So this one represents x approaches 1 from the left, and next x approaches 1 from the right. So limit of x squared minus 7x as x approaches 1 negative will be 1 minus 7 times 1, or negative 6. And the right-sided limit, or the limit as x approaches 1 positive of the function g, which is the limit of a x to the third minus 5 as x approaches 1 positive, equals a times 1 to the third minus 5, or a minus 5. For the two-sided limit exists, the negative 6 equals a minus 5, or the left-sided limit equals the right-sided limit. Therefore, the value a is negative 6 plus 5, or negative 1. That's the answer for the value a. And then the limit value, the limit of the gx as x approaches 1 would be the value negative 6.